we may try to get
sure
on more. But,
okay, so we're going to talk about defining. I'm going to start up again. People will sort of come back in anyway. So defining a class. We've seen defining a function so far. Defining a class is. Let's have a look at this. This is what I would call the Java-esque kind of long form. It's Scala code, but this is how you'd write a class in Java. You have your class, you give it a name, you open curly braces, then you would define some potentially mutable state at the top, like the private var sum. What we're doing here is actually putting a checksum accumulator together, by the way. And then you define a method called add, and that takes a byte and it returns a unit. And what that does is adds, it's side effecting, that's why it has a unit return type. It adds the byte to the sum, and then we have a method checksum down here, or function checksum, and that returns an int, and what it does is it takes the sum, masks it, does a, what is that, a not?
Bitwise complement.
Bitwise, yeah, and then adds 1 to it for, why did we add 1 to it?
For fun.
Just for fun, okay, fair enough. All right, so that's our checksum.
Yep.
That's the Scala way. This is more, sorry, that's the Java way. This is more what you'd see in Scala. One of the things I found really liberating about coming to Scala is I just dropped a lot of the kind of Java best practices, which basically means, I think in Java, if you look it up in the Java dictionary, best practices means more typing, as far as I can tell.
More finger typing.
More finger typing, yeah. So, yeah, not more strong typing, just more finger typing. So this is equivalent code to what we've just seen, but a bit shorter. Some of the things to point out: the add method now, the add method is actually a procedure. It doesn't have a return type. And before we said :unit equals. Okay, that's kind of useless. It's noise, because what it means is we're not interested in the return type of that thing. So an equivalent way of doing that is simply not put an equals on there. If you don't put an equals on there, then it says, oh, well, you're clearly not interested in the return type, so I'll make it a unit. And
yeah,
so
it forces it to unit.
Yeah.
Even if you forget the equal sign, then it goes to unit also. That's a common gotcha.
Yeah. But that's a procedure that we've defined. Likewise, the checksum, we've defined it. We've got the return type on there, int, and then we just put it all in line. No extra curly braces. Much more compact. Quite readable.
But this one, you could leave this int off.
Yes.
Because it would be inferred, but the best practice, not best practice, what we tend to do is on public methods we put it in anyway because it adds sort of documentation.
It adds documentation and it catches errors sometimes too.
Yeah.
There are occasional errors that sneak in. Okay, what's next? Okay, so now let's talk about something. So in Java you have static methods. Static methods, you don't need an instance of something to call a static method. You just you use it from the class directly.
The class name dot. The
class name dot, and then you give it the method. Scala doesn't have statics, and statics are always sort of a bit of an odd thing to have in an object-oriented language anyway, I think. It was to work around particular problems that you'd have, and it was to allow you to do things like factories and stuff like that. In Scala, what you have instead is you can have this thing called a companion object. And to be a companion object, well, first of all, we should talk about objects, really, shouldn't we?
Yep.
So what we've seen so far is the definition of a class. Definition of an object is very similar to the definition of a class. You just stick an object keyword in there instead of class. You give it a name you had before. The difference is it's the same kind of definition, but you get back exactly one of those things, and only one of them. And the instance corresponds to the class definition. So when we do this, if you can...
I was trying to think of how to demo, but I can just say object Fred or something like that.
So now we've done Fred. Fred has nothing in it, but we've defined kind of a class Fred, and we've also given exactly one instance of it, also that goes by the name Fred.
So I'll just make him a greet method. Give Fred a greet method that prints hi. Notice I left the equal sign off there.
Yeah.
So now I can say Fred.greet. So it's kind of like calling
it's a bit like a static
method, right? But what you really have, Fred is a variable that refers to a real object in memory and on the heap that has this method. So I'm calling it on the one and only one instance of that class that's get made behind the scenes. But you can think of it as one object sitting there.
And that's objects, and objects are a true singleton. This is you know, the gang of four singleton pattern. Objects are the true singletons in Scala. Now, when you define an object in the same file, in the same source file as a class that has the same name, it becomes what's known as a companion object to that class. And what that means is that those, and I love saying this because it's funny, it always gets a laugh, the object and the class can share privates with one another. That's an arrangement that they have. They're very good friends. And so that's just a special kind of arrangement that you get, but those conditions have to be met. The object has to be in the same source file, and it has to have exactly the same name. Then it becomes a companion object. And it's very useful to have that. When we saw before how you initialize an array, and you say capital A array parens 1, 2, 3, that calls the apply method on array. An array, in that case, is the companion object to the array class. So you get back an instance of an array class, but you're calling a factory method on the companion object. In practice, it looks very natural. You just say array of 1, 2, 3, and you get back a new instance of the array. And that's typically the kind of relationship that you have between a companion object and a class.
Yeah, so here I did create two, you have to do this in colon paste in the interpreter, but I made a class Fred and an object Fred, and they both happen to have a greet method. So the class Fred's greet method says he's a class. The object's greet method says he's a companion object, and then I said Control-D, and it defined both of them as companions to each other. And when I say Fred.greet, that's like calling the static method, right? It's actually this companion object that I'm calling it on. I have to create a new Fred to get the class, an instance of that class, just like you do in Java.
Yep. So that's
You do in Java.
Yep. So that's the companion object. And in this case, what we're doing with the companion objects is we've created a checksum accumulator. We're assuming that making checksums is pretty heavy operation, because it usually is. So we want to cache the checksums once we've calculated them once. So what we have here is at the top we have a private val of that's a cache, and it's a mutable map with a string and an int in it. And that is the string, whatever we pass in that's going to have the checksum calculated, and then if it's already done the work, it puts the resulting checksum in there. So what we can then do, if you look at the calculate method, that takes a string and gives back an int. And the first thing it does is checks, does this cache contain the string? If it does, we're going to use that. Otherwise, we're going to create a new checksum accumulator, which is the class. We're going to create a new instance of that class, calculate the checksum, and put it into the map before we hand it back. And so now, when we say checksum accumulator.calculate, we always go to the instance, the single instance of this guy. We ask it for the value. It checks the cache, and then it calls through to the worker if it needs to. The class.
We have a diagram. So yeah, here's kind of a diagram. This is the variable. It's just happens to have the name of the object, and then holds a reference to the singleton object, and that has the cache in it.
Okay.
So.
I think I'm going to call a bit of an audible at this point, because we won't get to it today otherwise, and I think it's valuable to call an audible, you know.
See, I'm always learning British expressions.
No,
right?
that's American. That's American football. Call an audible.
Okay.
You know, Blue 22. I'm going to change the play. So what we're going to talk about is case classes really quickly, because we won't get to them today otherwise. So one of the places where companion objects and classes are used very effectively together are these things called case classes in Scala, and they're sort of the ultimate implementation of value objects in Scala. They're very useful. When you create a class, you just get a class. When you create a case class, you actually get quite a lot of stuff. So if we create a person, maybe with a first name and a last name.
So we haven't done this yet, but the way you make the constructor is you just put it next to the class. So I'm going to say name string and age. What these two things are basically the constructor parameters. When I make a new person, now I have to give the name Bob and the age 29.
Yeah.
I made the age a string. I don't want that. I want an int here for the heck of it. Okay.
Yeah. So that is how that so far, although this is a case class, we're using this just like it was a class.
Yep.
However, some of the differences, when you do this, you get a companion object implemented. So now we can say person
person dot
directly.
apply. I could do that.
Yeah,
right?
you could say person dot apply
and,
Bob.
29. Whoops, and that's the factory method for persons.
Yeah.
And of course, I can just leave off this. And what it means is I don't have to say new anymore.
Yeah. So that gets you something that's quite nice. There's a few other things that we're not going to go into because they're to do with pattern matching, but you get some other stuff like the ability
Well,
to...
you get equals and hash code.
Yeah, equals and hash code is important.
You
So
get a
yeah,
copy
you get
method. So
you get
let's
an
say-
equals and a hash code that works, and now you've got, you've just cut out, I don't know, 20 lines of Java code in your equals and hash code implementations that is done for you.
I also get a nice method copy that
Yeah.
allows me to transform an object to something else.
Yeah,
to
so by
change
default,
something.
the fields are immutable because Scala likes immutability. So the case class fields are immutable, but you have a nice copy method, which gives you a new a new instance of the case class back with whatever you've asked for changed in it. So what you're getting is you're getting the benefits of immutability, but without a lot of the overheads of having to. It's much easier to create new instances with things changed. The copy method is very good for that. And then you get a nice toString. As you can see,
Oh, you see it right here.
when you see,
Like this is the toString output right here, for
yeah,
example.
that's the toString. So it
So
actually
it writes a
tells you,
bunch of stuff for you. And so all I did to get all that stuff was put case in front of it. But you can basically just make a class like this, and you have to write it yours. Oh, it doesn't let me. I need to rename it something else. Person2 or something.
yeah,
Then you can write that stuff yourself if you want.
right. Case class is just a nice, easy way of creating value objects, and it was worth mentioning. Okay, Scala application. So this is where we get into the, and I love the first thing people learning Java, the easy language Java, is they have to learn public static void main, args, or string, square brackets, args, and all that lot. And hello, what now? What is that? So this is the equivalent. So the public static void main thing is to do with the fact that you need a static method. You've got to have an entry point into this thing. And because you're coming into the program, you can't create any instances ahead of time. So you've got to have a static method. It's got to be public so it can be seen. It's void because there's no return type, another kind of weird thing that is, a bit strange. And then the thing itself is called main. The equivalent in Scala is this. We don't have statics, we have objects. So you create an object called with whatever name you want, the class. There's no public keyword in Scala, something we haven't talked about yet. By default, anything that is defined is public. Okay, anything that's defined in a class is public. If you want it to be private or protected or something like that, you use those keywords. Those keywords exist. But by default, anything you define like a method or a val, that's public. So you don't need public in front of it. Then you say def main. You give it the arguments, which are an array of string. And then it's a unit. The unit is kind of the equivalent of void. So we just don't put any return type on it. We just say open curly braces. And then we can do whatever we want in there. So this is how public static void main translates to Scala. And it's easier, I think, to just say def main and give it those arguments, but there's an even easier way. This is the new approved way of doing it, much easier. It reads really nicely. You just say object summer, object summer extends app. Okay, and we haven't really covered traits, and I'm not sure we'll get as far as traits today, but app is a trait that says this thing can be treated like an application. And when you do that, you don't have to put anything else in there. You just say summer extends app. And then you get the args is available to you automatically in scope. So you get that stuff. Just a much cleaner way of writing it. So those are equivalent. Compiling and running. Two things to talk about here. Actually, this is time for the joke, the rather stale joke. At least it's stale to us. People who don't know Scala, or they have a tendency to complain that it's too complicated. It's a really, really difficult language to, all these rules and stuff like that. People who use Scala, they don't have that complaint, but they still do have a very specific complaint. Everybody who uses Scala in anger complains that the compiler is too slow. The reason for that is it does an awful lot of work for you. But one of the things that you want to do with the Scala compiler is you want it running as little as possible because it works so hard. And a full clean build can take a long time on a serious project. So Scala C is the equivalent of Java C. It runs the Scala compiler, it compiles a bunch of stuff, and then it exits. And that's, kind of the life cycle. FSC is the kind of antidote to slow compilation. FSC starts a daemon running in the background. And this daemon does your compilation work for you, but it doesn't exit. Okay, so win number one is it doesn't start each time. It doesn't have a whole bunch of initialization to do. But much more than that, FSC actually figures out what it's compiled before, even to the level of not recompiling an entire class if just a single method changes. It's very good at aggressively optimizing out the work that it needs to do. So the result is when you run FSC, when it's heated up a bit, when things are running well, it actually gets quite fast because it's not doing a lot of the work that it would have done otherwise. It's very smartly trying not to redo a whole bunch of the work it's done. So you'll find that FSC is used by a lot of stuff. SBT in particular uses FSC aggressively to make things compile fast. The downside is you want as much memory on your laptop as you can possibly get because FSC is no lightweight. It keeps a lot of stuff cached. And so, yeah, 8 gigabytes, that's a good starting point. Get a lot of memory in your laptop if you're using FSC. Life will be good.
So then the way to run something, once you've compiled it, is this Scala it's the same Scala executable, and then you say summer. That's the name of a class that has a main, a companion object that has a main method.
Yeah. And the other thing I want to mention here is that in this form, when you call Scala like this, there's actually nothing very special about this. You could actually call summer of love with Java. You could type Java summer of love. But the only thing is you'll need the runtime libraries for Scala on the class path if you do that. Scala, when you type that, just calls Java, but it puts the libraries onto the class path for you so that they're available.
Yeah, like this.
Yeah. Will that work?
No, because I don't have summer of love.
Okay, never mind.
I left that in San Francisco.
That's what it does anyway. Right, okay, primary constructor. So when you define a class, actually you just do class thread again. And no, just hit return. Okay, that's a class definition right there, okay? It doesn't do much, it's not very useful, but that's a fully complete definition of the class thread. So there's no need for open, close, parens. There's no other ceremony about it. There's no other ceremony about it. When it comes to constructor parameters, in Java, you do the stuff that's at the bottom here.
Yeah,
okay, this is best practices Java. You have the class definition, then you have a couple of final private values in there because you should make them final, right? Nice, good Java programmers should make immutable objects whenever they can. And then you need an actual constructor that's defined with the same name as the class, and you pass in the parameters, and then you assign those parameters across. And there's a lot of stuff.
I actually
that
say
you're writing
N
here.
4 times and D 4 times.
Yeah. Now this is a violation of dry a lot. I mean, there's like repeats all over the place. Plus, there's this really weird thing that you've got these finals, and you're assigning something to them. Okay, we all know the rule that you can do that in a constructor, but that's still really weird when you think about it. You're making this thing final, but it's kind of final almost. It's almost final until you're out of the constructor, and then it's really final. So the equivalent in Scala is what's at the top there. That's what you need to define. You just rational, and you give it the numerator and the denominator, and that has just done everything that was in the other definition there.
So one of the goals Martin had was he wanted to make it more natural to use immutable objects, and in Java, just because of that assignment, it feels a little unnatural. It feels a little immutable. You actually have to mutate these variables to initialize the object. So he just kind of hides that behind the scenes.
Not to mention that you've got to do that every
Well,
time
you
you define a class.
Yeah,
I mean, life's too short. You could be drinking wine. So, so anyway, this is, now as far as actual code in the constructor though, so what we just did was created our constructor, but where do we put the code if we want stuff to actually happen in the constructor? Well, anything that's inside the class that isn't in a def, well, the vals kind of are, they're initialized, yeah, so they're part of the constructor. Anything that's not in a def, that's actually part of the constructor code. Okay, so anything inside the curly braces that's not in a def gets run when you make a new instance of that class. So here, we've put a print line in there. When we create a new rational 1, 2, it actually runs that print line. Okay, and if we put val statements in there, it would evaluate the val statements. Those val statements would have to go before a place where we use them in the code, because it's like it's running that code sequentially. So if you use a val, you can't just define it somewhere further down. You can if you're using it in a def. Did I say val again? I did say val.
You were going to say var just now, weren't you?
I didn't say var.
I'm starting to see it coming.
Yeah.
You can change your behavior.
Okay. But anyway, yes, so if you use a val, if you refer to a val,
yes.
then you have to define it first if it's in the constructor code. So that's how you do a constructor. And this is called the primary constructor, right? So I think we're going to move on to auxiliary. The primary constructor, right? So I think we're going to move on to auxiliary ones next, aren't we? Oh, okay.
Not yet.
Next up, the print line. The print line that we had in there.
It's this one. It's James Gosling's, the Java print line.
Oh, no, I was talking about the fact that you've actually got a print line in the constructor.
Oh, this print line.
Yeah, that's not really what you do normally.
Yes.
What you would actually do is override the toString, so that when you do a toString on this thing, and the REPL does the toString for you when you're using this interactively, when you get back one of these things, it just does a toString on it. So before, we got the rational at 465E34CE. Now, by defining a toString, we get a half when we do that. Oh, you're doing the new.
I'm going to try it.
The new super duper. I think you need those in
We're about to find
curly
out.
braces.
Nope.
Those things. Oh, okay. Interesting. I thought you need
non-identifier character.
Non-identifier. Okay. So rational. We now have a toString. One thing to notice is the override. Override's another keyword in Scala. It's not optional. If you are actually overriding a definition, it's a compile error if you don't specify override. So this is different from Java, where you have the at override, but it's not a compile error to leave it out. In Scala, it actually is. If there's a definition that you're going to be hiding with your own definition, you need to specify the override there. Okay.
So this is string concatenation like in Java. This is a substitution form that's available in 2.10.
Yeah.
Where you can put the $ variable names in there.
String interpolation. Okay, checking preconditions. So we're going to make our rational a bit more sophisticated now. We're not going to allow zero denominators, because that would lead to a divide by zero error. So we have a nice handy little method or function defined called require. And all that takes is a predicate and a message. You can actually use it without the message, but that's not recommended. You should always put a message in there. And what that does is checks that the denominator is not zero. And if it is, it will throw an exception. It will throw an illegal argument exception. So that's a nice little bit of error checking when somebody creates our fraction. Yeah. Now we get a illegal argument exception. Good. What's next? You can only access class parameters on this instance. So actually, during the break, somebody asked a question about mutability, and I mentioned a scoping called private this. And private this is a scope that doesn't exist in Java code, but it does exist in Scala. Private this means that this item, this value, is only available in this specific instance. Even another instance of the same class can't use that. It's very, very tightly scoped. And in this case, when you use constructor parameters like this, they come in as private this. Okay? They're as private as they can possibly be, which means that you can't refer to D in another instance of the same class, okay? Because it's private to this instance. So this is a compile error. It says value D is. So this is a compile error. It says value D is not a member of rational new blah 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 blah. What you can do instead, there's a couple of different ways to do this, and we're going to skip ahead to the right way. This is the way that we teach, because it's not magic. It doesn't show a whole bunch of stuff going on. But what we actually do is we create vals, denom, numa and denom. They're public by default because there's no public keyword, but anything that's defined inside of the thing, unless otherwise specified, is public. So numa and denom, in this case, will get those values, and then they can be accessed from outside. More common is to actually stick a val in front of the n and the d in the constructor. Okay, and that makes them public. So you would put a val n and a val d in there. It's very idiomatic. These things are private. These things are immutable anyway. Parameters are immutable. So where's the harm in actually exposing them as part of the public API? It's what you're doing anyway with the NUMA and denomic API. It's what you're doing anyway with the NUMA and denom. It's just a bit quicker to do it that way. Okay, self-references. Much like Java, won't come as any surprise to know that this refers to the current instance. So just saying this less than that else this is an example of that.
So this could be a method inside rational.
Yeah.
That works the same.
Auxiliary constructors. So this is, you may be asking at this point, well, if my constructor is part of the class definition, how do I have different constructors? How do I have a constructor with a different type signature? Well, the way you do that is you say def this, and you give it a different type signature. It has to be a different type signature, otherwise Scala doesn't know which one to call when you
yeah,
when
it's
you
just
invoke
Java's overloading rules.
Yeah, exactly. But what you do is you define the new type signature, and then you say equals this, and you give it another constructor. Okay? That's important. It doesn't have to be the primary constructor, but it does have to be another constructor. Eventually, they're all going to have to go up to the primary constructor.
Yeah, so this body looks pretty similar to Java. It's basically Java's constructor body. This one just, all it does is call the other guy, but it's the same kind of rules where you got to call this first, except you can't call super. The only guy that can kind of call super is the primary, so that's one way where it's more restrictive. That's,
yeah.
So.
Okay, defining, oh yeah.
The other difference is you don't, instead of the name of the class, it's this. That's another difference from Java.
Okay, go back a slide quick, because, okay, this is the next thing I want to talk about. So, contrary to popular belief, Scala doesn't actually have operator overloading. Operator overloading is a charged term that has got a very bad reputation from a number of different languages over time. What Scala does have, we've already seen the ability to use infix notation. Okay, that means when you call a method on an object and it has one parameter, you can drop the dot and the parens and you get the infix notation. You just put spaces in there. What it also allows you to do is have symbolic method names. Okay? Put the two of these things together and it looks a lot like operator overloading, but it isn't. You're actually defining a method called plus, okay, that can be called with dot plus parens. But when you use it with infix, it looks very natural. It looks like A plus B. So that's what we're doing here. If you look at the screen...
The only thing that's going to change is this.
What's that?
It's going to change from add to plus.
That's it. And that's how we define the plus, okay? Now, there's been a lot of back and forth over whether, operator overloading is a good thing or a bad thing, and it can certainly be abused. But really, when you look at it like this, is it any more abusive to use a plus here than an add? You could still make add remove something or wipe the contents of your hard disk. Just because it's called add rather than plus, that really doesn't make any difference. Okay, it's all how you look at it. You can always write bad code. Operator overloading doesn't mean that the code you'll write is going to be worse or better. It's just another tool in the arsenal. So, anyway,
you can and this is another example, I think, of Scala trying to make things general so that you can make libraries feel natural. Like it's like as if there was a built-in rational number in the Scala language, but there wasn't.
Right.
Number in the Scala language, but there wasn't.
Right. Okay.
Oops.
Defining operators. So yes, now we've got a plus, but we can only with the last one we can only add another rational. What if we want to add an int? So what we would need to do is define an overloaded plus that takes an int. Okay, same rules as Java. We now have a plus that takes a rational and a plus that takes an int. And all that one does is just adds the rational times, well, plus the I times the denominator of this one, and then the denominator. So now
we can say new val a equals new rational. Sorry.
That's all right.
1, 2, val
and then you
b
can say
equals 3, 4. Let's make that a 3/4 or something, or a 5/4. Why not? 15/4. Okay. So I can say a plus b like before, but I can also say a plus 1.
Yeah. Okay. Now what happens if you do 1 plus a, Bill?
1 plus a.
Oh dear. There's a bit of a problem there because we've got a rational. We can add ints to our rational, but we can't add a rational to an int. right? There's a problem because ints don't know about
And
rationals.
the reason
We've
is
just
because
invented
over
them.
here on that Scala doc page, if you look up the int class, because what the compiler is going to do is going to go over to int and look for a method called plus, and it's got quite a few of them here, but none of them take a rational, right? So an int does not know how
To take a rational.
add a rational to itself.
Right.
So that's a type error.
So what can we do? We want a nice API. This is where implicits come in handy, and actually the API. This is where implicits come in handy, and actually, how do you fancy a bit of stunt coding and doing the 210 implicit definition for
okay,
this?
yeah, sure.
So let's do that. Let's do a... oh, actually, you don't need to because you actually do want to do a type conversion on this one. Let's save that for later then.
Okay.
So what we want to do is we want to be able to treat an int as a rational. That's kind of our way of getting around this. If we know we can make a rational out of an int, we've even got a constructor to do it. The thing is, we need to, if we know we want to add a rational to it, then we need something that says, okay, let's make a rational out of that int so that we can add another rational to it. And that's what you do with an implicit definition, so an implicit method. Now, this is now a restricted feature in Scala 210. This is something the...
What is the import? I don't know.
Import
Scala language dot, I don't know.
Yeah, language dot something.
Dot implicit conversions.
Implicit conversions, there we go. So
do I see dot? No, I think
in Scala 210, this is something that you have to say, yes, I really want to use this. It's a warning right now. In future versions of Scala, this will actually be an error unless you specifically import this feature, because it can be confusing and it can be abused. But library developers really want this. Okay, you can't just say, "Oh, get rid of the get rid of the thing." This is a common thing I hear: is Scala's got too much stuff in it. Let's take some of it out. At which point I say, "Okay, what do you want to take out?" I use every single one of these features very effectively, and I wouldn't want to do without any of them. Okay, it's all very well to say it's got too much stuff in, we need to take some out. I don't want to lose anything. It's all really useful as a library developer. So, so this now is an implicit definition. It's just like a normal definition. It takes an int and it wraps it in a rational. So it takes an int, gives back a rational. But by putting implicit in front of it, we could use this without the implicit. We can actually say int to rational 2 plus a half, and that would work, okay, obviously. When you get something...
that's a good idea. So int to rational 2 plus a. That's basically, I convert that 2 to a rational that has that 2 value 2 using that method we made, that overloaded method that takes an int. And then I add a to it. But you don't, it will do that for you now that implicit is in scope.
The kind of good usage style of implicits, and this is what they're for, this is why they're called implicits, is if you've got something that you use ubiquitously, if it's something that you find yourself always doing in the code, and you have to write it out, Scala gives you implicits, so you don't have to write it out anymore. You mark this thing as, this is pretty much ubiquitous. Once I import this feature, I want it to be available everywhere automatically. And that's what the implicit does. So it says, okay, I've got an int, I need to use it as a rational, because the only way I can add another rational to it is if it's a rational. It won't convert anything else, because one of the rules of Scala that we've covered is Scala won't do any work until it knows something won't compile. Okay? First of all, it'll take your code and try and compile it. If that compiles, fine, it moves on. If it doesn't, then it starts to look around for something that will fix the problem. And what it finds is an implicit in scope that takes the int and turns it into a rational. And guess what? There's a plus of rational to rational. So we've solved the problem. Scala uses the implicit for you.
It essentially takes this code and rewrites it to this code.
Right.
For you.
And this is how Scala does extension methods.
So the implicits are, there's really constrained rules. There has to be, they can be any name, but it has to be just available as a simple name. You can't say a.b.c.int rational. It can be only one, and only one can solve it. So if there's two that solves it, that's also a compiler error. It says it's ambiguous. There's quite a few restrictions on it. But it has to be in scope. So you have to import it, or it has to be something you inherit. There's rules for that too, but it's
right. What's next?
For that too, but it's
right. What's next?
Next.
Oh, exercises, right.
Slide 4.
Slides
Go back
4.
to that. I think I want to close that. Yes, I do.
Any quick questions while we're changing slides? Yes.
With this infix method calling implementation, how do you define order?
That's an excellent
Yeah,
question. So
repeat
the
the
question
question,
is, with the infix methods that have symbolic names like plus and times and things like that, what happens with the ordering? That is a great question. So they are just method names, but Scala does have a precedence ordering defined for them, and you can look it up. It's what you'd expect. So multiply is higher precedence than plus when you use that.
The rule is you look at the first character in the name of the
Yes.
method. In this case, it just has one method, but I could name a method star 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 or whatever, right? It looks at the first character, and then it takes that character and looks it up on the table. It's the same. It's very. I think it's the same precedence table as Java has for its operators. So.
Okay.
Yes.
Another question.
If you have multiple implicit conversions that can all succeed.
Oh, if you have, so
Yeah,
if you have
repeat the
multiple
question,
implicits, question is, if you have multiple implicits that can all succeed, which one does it use? It doesn't use any of them. It's a compile error if there's more than one implicit that could apply in a particular situation. It's ambiguous, and the compiler will tell you that, and it will tell you which implicits it's found that satisfy that. There are some exceptions when there's one implicit that is obviously much more specific to your case than another one that's very general. And when Scala can figure that out, it says, well, clearly you want the more explicit one, the more targeted one. So I can use that. Sorry? Overloading methods?
Yeah, if you have several methods of the same name in Java,
Yes.
with same number of arguments but different types, Java selects the most.
Right. Yes, it's like that. So it is like method overloading. It selects the most.
It is actually very similar to that.
Yeah.
But basically what he said was, is it like the way Java selects which overloaded method to call based on the types, which one's the most specific? It's actually very similar to that.
It's in practice, it's very natural using implicits, because if you can read it and it's obvious which one to use, Scala agrees and it uses that one. If there's any doubt, like you've got something that converts a string to an int, and there's two different ways you could do it, you look at the code and you go, well, yeah, which one's it going to use? Scala's not going to use either of them. It's going to give you a compile error because it doesn't know either. Okay.
Let's zip through some of these.
So I think we can go
turn.
very. Oh yeah.
Yeah. So if
We can go very fast.
we can
on
just
these.
skip this one. This is one thing I wanted to say about this, though, is just this is kind of a refactor that I did when I did this thing on top 100 times or 100 times, 1,000 and 10,000 times in Java and before. I would initialize a var with a default, and then if something was true, I'd change it. In Scala, you try to get rid of those vars, so what you would do is you'd make it a val, and then you just have an if expression. So it's just a slight change, and it gets rid of a var. And the benefit, really, the practical benefit, is I know that file name will always be that. I don't have to look down to see if it was ever a change. Because most of the times, a lot of times when I'd make a var in Java, I did never change it. So you may as well say that.
Yep.
Next. Yeah, we said that.
Balanced opportunity. Yeah,
Prefer
try and
vowels.
use vowels. Yeah.
There's while loops and do loops. Just like in Java, they work the same. This GCD loop method calculates the greatest common divisor using that technique, and it's got like 1, 2, 3, 4, 5, 6, 7, 8 lines of code if you count that curly brace. And I'll show a functional way to do that shortly. The one thing that I did want to mention, and the do while is also, just puts the condition at the end. So why don't you go to the next one? Yeah, there were a lot of vars on there.
yeah,
What the heck is that actually? Var alert. I think they're actually doing that when they see vars now. We talked about unit already. So the one thing I did want to point out here is that this idiom from Java does not work. Line equals read line does not equal empty string or like end of line or whatever. An assignment in Java had the value that you put in.
Yeah.
And in Scala, it's just unit. So what you have to do in Scala is this second thing here where in curly braces I say line equals read line semicolon. And and then I just say the result is line. So that shows a couple things. One is you can put semicolons wherever you want in Scala, just like in Java. It's the statement
optional.
separator.
Yeah, they're usually
They're
optional.
usually inferred and don't need them. But here I'm actually using it to put two statements on one line. You can make curly braces, you can just stick them anywhere, and that makes a sort of a new scope. And the last expression inside that curly inside that block is what the result of that curly brace block is.
Yeah,
So
that's very handy.
so this is the functional way to do that 8-line while loop that was calculating the greatest common divisor. So you want to also get rid of while loops if you want to do things in the functional way, and sometimes that, a lot of times that means you need to make something recursive. So the recursive way of doing...
I can put it in here.
Yeah.
So I can say GCD of 9 and 3 now. That should give me 3. That's good. Now there's something definitely worth mentioning here, though. This is, much more compact than the while loop, and it doesn't have any vars in it, or it doesn't have to have any side effects. But the other thing that's really important about this is it's just as efficient. So I can import this annotation just to prove it. You don't actually need to put this annotation on there, but this is a tail recursive call. It means that in this situation, the last call in one of the execution paths of GCD is a call back to GCD. Okay? And Scala can do a trick with this situation where it eliminates the stack descent. It eliminates the actual function call, and it turns this into a while loop for you. And it can
in
do
the
that.
bytecodes, it's a while loop.
Yes, so there's no performance penalty to doing this. You get the style of functional programming, and behind the scenes you get the performance of the while loop. And I can show that by actually putting an @tailrec in front of it and pasting the same thing.
Yeah, there you go.
And that will actually not compile now if it's not tail recursive, if it's not able to do that tail call elimination. So you can ensure that your assumptions are actually correct. In that case, it's easy to look at. Sometimes it's not as easy to reason about whether this thing is going to be tail call optimized. If you stick an @tailrec on it, it will tell you whether it is or not.
Yeah, so that's also idiomatic, because to the reader of the code, it says it's tail recursive when you look at it, and it's tail recursive when you look at it. And
right.
okay, next. For loops. I call these loops because they have a side effect. So for I in 1 to 4, do something. For I 1 until 4, maybe you can show those in the interpreter, what those give.
2, 4 gives you a range that's 1, 2, 3, and 4. 1 until 4 gives you a range 1, 2, 3.
Yeah.
So it doesn't include the last one.
Okay, so if you go back, so basically I'm iterating.
Include the last one.
Okay, so if you go back, so basically I'm iterating across that range. I get a collection. And it's not common to do this last thing, because that's how you can have the off by 1 error when you're actually accessing elements. But sometimes you need 1 to 4 or something. So let's go on. And this is a filter. So 4 expressions have quite a few more features than just 4, just looping. Right there I say for file and files here. So files here is going to return some list of files or a sequence of files or a set of files or something from the file system. I actually stick an if. And it does the same thing as this thing down here where I say for files and files here, if this is true, it ends with Scala, then I print it. But it does it by rewriting it to method calls. So when you stick it up there, this file and files here gets rewritten to a for each, and the if gets rewritten to a filter, or maybe a map. But anyway, they rewrite it to file names. So go on to the next one. And when you have multiple things, you can actually space them out. And so if it just fits on one line, I tend to make my 4 expressions all in one line like that. But as soon as I start having a number of things in there, we tend to start doing them vertically like this. So the first line is iterating across the file names return from files here. Then I say if it's a file and it's named in with Scala, then I do the print line file. So
next one.
Yeah. And another thing you can do is multiple iterators. So I have, well, not iterators, generators are called. Files here is like a generator, this thing. So I say for files and files here, if the name's in Scala, now let's grab the lines out of that file. For each one of those lines, after you trim it, it matches whatever pattern I'm looking for, then I'm going to print it out. And that's called grep, right? Okay.
Yes.
And
Now, one thing to notice about this is right now we're using for in parens, and there's a rule that inside of parentheses, semicolon inference is actually turned off. There's a couple of different rules, but what you can do, because you know semicolons, after you've let go of them for a while, they really jump out at you in the code. It's like, ugh, there's a semicolon. It's like it's seeing a cockroach or something.
I kind of do, yes.
So
It's like seeing cockroaches.
you can actually use
Yeah.
curly braces.
So what's really
and-
bad is if you guys do some Scala programming on the side and then go back to Java programming, you keep
Oh.
forgetting semicolons.
Yeah.
That does happen.
That's
So
not
here, I've changed those parens to curly braces. And it just means the same thing, but semicolon inference is now enabled, so I didn't have to put that one semicolon anymore. But the other thing I'm doing here that's new is trimmed equals line.trim. That's like setting a new val, but I don't have to say the word val. So that's midstream assignment, because what had happened before is I calculated, I called .trim twice. So if that was like an expensive operation, I could just do it once and set it to a variable, a val, trimmed, and then I use trim twice. So that's that's all the things you can do in a for expression. You can do generators, which is the left arrow. You can do if, those are called filters. You can do
Midstream assignment.
midstream assignment.
Yep.
Yeah, that's it.
You
And
can
you
also
stack
do,
them all
you
up.
can also do things like method calls in there, of course.
Well, inside those things,
yeah,
you can do
yeah.
whatever. So
Right.
those are the three things you can put in them, and you can stack as many of them up as you want. And then if you say yield, that's what really makes it a for expression because it has a result.
Yeah.
And so instead of having a side effect, I'm now have a result. And one of the things that is a kind of a gotcha in the early days when people first start using Scala is they try to put the yield inside the block, but you need to have the yield right at the beginning of the before the block, essentially.
Right. If you need
Yeah.
a block, you just say yield,
And
and
then
then you
open.
open curly braces, and then you do whatever you want to in the curly braces, and the last thing in those curly braces will be evaluated and given back as the result.
Sorry, still laughing at the semicolon cockroach. I think that's,
It is
that
kind
is,
of like
it's
that.
like,
Oh,
I don't
semicolon.
want to touch that.
Fetch the bug
Okay,
spray.
Next. So here, for example, I start out with an array of string. Files here returns an array of string and goes through all the way, and I say yield trim.length. That type is an array of int. So you end up with I end up with the same collection type, but I've changed the type parameter.
Yep. Okay.
Yep. Okay, so now this is Scala is on top of the JVM. It has exceptions. So exceptions aren't functional. Functional is you just always return a result and you don't have any side effects. That's pure functional.
The problem with exceptions is, and it's a real problem when
water.
you're doing a heavy computation operation, is they interrupt control flow. Okay, they interrupt your code flow. They stop something happening in the middle. If you're calculating 1 million numbers, and you've got to 999,999, and there's an exception, you get nothing back. It's done all that work and it's thrown it away. So, you know, when you're really number crunching, exceptions are the enemy. There's better ways to do things.
But what they are good for is throwing things up way up the call stack where somebody can handle the error, as you know, what the same thing they're good for in Java. And the way you do that is throw. Looks just like Java. So throw new, you got to create a throwable. And what the type of throw is nothing
Yeah.
with a big N.
We're gonna
So
talk
there's a
about
type
nothing.
called nothing. Because if you throw an exception, you really do return nothing, right?
Actually, let's just
And
do
nothing
error.
is a bottom type in the hierarchy because everything, it is a subtype of everything. And what that means is that when he makes this method error that always throws a runtime exception with the error in it, the type of that, see the return type there to the right of the paren is nothing. So it will never return, actually, anything.
Yeah. And another quick example for this is if I say val x's equals list.empty, okay? What I actually get back is a list of nothing.
Yep,
Okay,
that's a
it's
good
the
example.
bottom. It's the bottom of the hierarchy. Now, if I put something onto the beginning of that list, like an int, okay, it's going to give me a new list back, and it's going to infer the most specific common supertype of all the things that are in the list. Because nothing is underneath anything else, what I'm going to get back is the int. Because
nothing is a subtype of
underneath
int.
int. Okay, and then I can do, onto this, I can do 2.0 and put that on the front, and then I get
Keep
an any
going.
val, and it goes on from there. But nothing is at the bottom.
So
So,
type NIL, capital NIL, type nil. I was mentioning that's the one and only one
oops.
empty list. That's a singleton object, and its type is list of nothing.
Yeah, it doesn't
And
actually
it doesn't
show that.
show it, but that's what it is. Type is list of nothing.
Yeah, it doesn't
And
actually
it
show
doesn't
that,
show
but-
it, but that's what it is.
Yep.
Okay, so let's go back and see where, I forgot where we were here.
Try catch.
Okay, so that's how you throw them, and try catch is similar, except the catch clause, I mean, similar to Java, but the catch is a different syntax, and try is an expression. It can have a result, but this is just how you would do it in Java. I can say try, well, I created a new reader. I should actually have a finally clause. We'll show that next, but
Yeah.
well,
Well, the
in
other
try
thing to
block, this is
notice-
what I'm protecting with the catch, and in the catch you say case EX colon throwable, or
Yeah.
case EX colon file not found exception, and then you have a rocket.
And
So
then
it's
you
just
do
a slightly different syntax. And this is the pattern matching syntax in Scala. It's the same when you just do a pattern match, which we'll show a little bit in a little bit.
Yep. Okay.
Okay, let's do the next one. So the finally
Finally.
is also similar, and this is the same idiom in Java. The same idiom in Scala is you create a resource that's a non-memory resource, and you try right after that, use it, and then in a finally, you close it.
By the way, the curly braces are also optional here. So if you do try and you've just got a single method call, you could just say try single method call finally file.close. You don't need any curly braces at all if it's just single statements. Okay.
So this is the an example of try yielding returning a result or having a result type. What I can do is I want to return a URL for a string, so I just say try new URL with that string, and if that works, that's the answer. That's the result of the try expression, and it will be returned here. Otherwise, if it throws malformed URL exception, that means it was malformed. Then I just say send back this other hard-coded URL. So I can put a value in my catch clause, I can have a value in my try, and that's the value. It's going to be one of those two values. So try is an expression. So this is pattern matching, and pattern matching is like switch on steroids.
Oh, it's awesome.
You say, instead of switch first arg, I say first arg match. So match is almost like a method call, but it's not. It's a keyword. But I say first arg match, and then curly braces, I have a bunch of cases. Syntax is you say case, and then you have a pattern, and then a rocket, and then it will look through all these patterns, and the first one that matches wins, and it evaluates the body on the right-hand side of the rocket. You don't fall through, so there is no need to say break. At the end, it will only just do one, and then it's done. And
Sorry.
you're writing up a little demo.
Yeah, I'm putting it in there. I just forgot my item before the match.
Oh, okay.
Chips and salsa, eggs and bacon, and then case of underscore means anything else.
Yeah, case of
Like
underscore is
default.
like the default case.
What? Oh, it's print lines. Never mind. Ignore the man behind the curtain. Keep going. I'll
Okay.
rewrite it to be the right one in my nice
Yeah, this
editor
is
here.
where it helps to have two
Oh,
two
yeah.
screens, because give me a
Oh,
two
yeah.
screens, because give me like a taste of the thing, and I'll go.
Next one.
Yeah, so the
There we go.
difference here, if you look at the previous one has a side effect. This one has a value. So a match is an expression also. Switch is not. That's one way that's different. I can say if chips matches,
That's
then salsa is the right. So you can demo that one. Let's show
Yeah.
a demo.
Okay, so def match it item of string equals
Equals.
item match. And I think I have an extra match in there now. Yes, I
Making
do.
me hungry.
I know. Is it lunchtime yet? So get rid of those blank lines, and that's our thing, and then execute that. So now I can say match, wrong window. Match it, eggs, and I get back a bacon. And if I say match it, foo, and I get back a huh.
Food.
Foo. It's on the brain now, man. All right.
Okay.
It's on the brain now, man. All right.
Okay. Let's move on. So that's match. I mean, that's actually just a teeny tiny sliver of match.
I don't
Match
even
is
know if
quite
it's
powerful.
worth including. I think we should delete this slide.
Yeah, let's just delete it right
Yeah,
now.
gone.
Delete it.
Don't use break.
There is no break or continue keyword in Scala, and turns out you don't end up needing it when you start programming in the functional way.
You really don't.
There
4
is
years
a
and I've not
break
used it.
construct in a library if you really want it, and that's what that slide showed.
Never used it. 4 years, not once.
So this is just kind of to show scope. Scopes work the same in Scala as they do in Java. For example, the var I equals 1 is inside this curly brace here in print multi-table, and so it's only it's available in the entire method, but not outside of it. This var j equals 1 is just available inside this while loop, and so on. As soon as you hit a closed curly brace, those variables go out of scope. But this is the imperative way to print out a multiplication table, and what I wanted to do was show how you might refactor this to the functional style, if you go on to the next one. So what happens a lot of times is you make little methods that do one thing, and those methods are functional in the sense that they don't have a side effect, they just return a result. So what this first method does is make row seek takes a row as an integer, so it's like you're making a multiplication table, so you start with row 0, 1, 2, 3, 4, 5, or row 1, I don't know if it's 0 based or 1 based, I think it's 1 based, because column's going from 1 to 10. And what it does is it just calculates the product and converts that to a string and tries to figure out how much padding it needs to make all the columns line up. And it does by multiplying this space times 4 minus the product length. So 4 is like, each column is 4 spaces wide. So I get how much padding I need, and then I just return padding plus prod. But because I said for call equals 1 to 10 yield, I'm going to get back some kind of sequence of strings. Each of them will be 4 characters wide for that row. And then what make-row does is it calls make-string. So once you demo make-string, that's actually a handy method.
So string, as I call it, because it's Scottish. So I can say list hello devox, and that's my list. And I can say res8.mcstring. And if I just do it on its own, it concatenates them. If I do it with something like comma in between, then I get hello, comma devox. And if I do something really wacky like
Oops, you need this.
Yes, I do.
Basically, you can put something before, in between, and after.
Because I like a bit of symmetry, let's have that.
Then I get symmetry.
Haha!
There you go.
It's wonderful.
Is that like a cuss word in the middle?
I think it is.
Okay. So that's make string or middle?
I think it is.
Okay. So that's make string or mcstring. So if you go back to the slide, so that's all I'm doing in this. All I'm doing is I'm taking this sequence of strings and putting them together with this other method. And if you go to the next one, that doesn't do much. You could actually put it up here.
Okay.
This is a method that actually returns the whole table as one string with returns in it. So what I do is I create a table seek by iterating from 1 to 10 for the rows, and I call that make row method that you just saw on the previous slide that brings back one string. And I just make string those and put a return in between them. And now what I get back is actually the multiplication table is one string. I could unit test that, and then if I want to print it out, I just call printline on that. So that's it. So it's more concise and a lot fewer opportunities for error.
Yes. Okay.
Okay, that was me. So let's see. You can do this one.
Functions and closures.
I'm going to do, which one of these is yours, you know?
That one.
Okay.
Okay, so yeah, we're going to talk about functions and closures. Anybody? It's too many people to ask. This is always fun. Difference between a function literal and a well, yeah, I guess we're getting a bit ahead of ourselves. I'll wait for when we get into it.
Reset.
Yeah, reset. Okay, start over. Okay, right. Let's go into this. So, what are function literals? Well, let's sneak up on them from the side. I think probably most of you at this point, if you've been paying attention to Java 8, have a pretty rough idea of what function literals are. But in Java, just like Java, Scala can have private methods. These are methods that are only available in the private scope that they're defined in. So if they're defined inside of a class, you can only access them from inside of that class. So an example is this one where we've got we want to find all of the long lines in a file, and when we find the line that's longer than a certain length, we are going to print it out. Excuse me. Jet lag. We're going to print it out with the length, with the file name, and then that line in it, or whatever. That's what it does. So we have this process line method, and the process line method is the thing that actually prints out the line along with the file next to it, and it's private, so we can't access process line from outside of this class. And this is good design for APIs, because you don't want an API with everything exposed to the world in it. Sometimes you want stuff that you use that isn't available outside.
And the only place it's used is inside this other method here.
Right, and that's key, because there's only one place that calls this. So one of the things that Scala lets you do that Java doesn't is, because there's only one place that this is called, we can actually put it inside of that other method. So if you can go to the next, there we go. So what we've done now is we've taken that process line and we've actually moved the definition of it inside of process file. So we've nested the definitions. This is quite legal to do. You can do this as deep as you want. In fact, you can nest, another rule of Scala is you can pretty much nest anything inside of anything else. So you can have classes inside, defined inside of methods if you want to. And inside of that, you could have an object defined, and inside of that, you could have another method defined, and so on and so on. You can go as deep as you like. There's far fewer kind of special rules about what you can and can't do. So we've moved process line inside of process file. Now, one of the things here is that now that we've done that, file name and width,
These two guys.
they're going to be in scope already, because we've moved them in there. So we can get rid of them.
Yeah. So this right here is redundant. I'm going to,
Yeah.
when I hit return, it's going to be the same thing with that missing.
Yeah.
See, this is
We
now,
just
the
got
only
rid of
difference is
them.
that's now gone because they're in scope.
Yeah.
I can leave them out.
So we've just simplified that. We've now got an inner method that knows what string and so what file name and width are, because it doesn't need, they're already in scope. So all we need to do is supply the line when it changes.
And what the
Okay.
compiler will do, by the way, is because it sees you're using the width and the file name inside the method here, is it will compile it into this.
Yeah.
It will compile it. It actually has to pass it in the bytecodes, but
Yeah.
you don't have to write it.
Right. So now, though,
Oops.
if you look at this guy, we've got process line defined, and we've still only got one call to it. We're just using it one time. So we're giving it a name, and we're using that name one time. And you look at that, and you're like, well, that's kind of dumb. We really don't need to do that. So the next slide, please. The option is get rid of the name altogether. So what we do is we turn this thing into a function literal. And now what we have is it's a function. It does something to something, but it doesn't have a name anymore. We can just, when we create it, we just create it and use it straight away. So here's an example of adding 1 to x, and that's an increase. Now, if we want to, we can actually assign it a handle at this point. This is a bit like saying def increase.
Well, yeah, I mean,
for x,
basically,
but
even if I just put this in here, I get one because it gives
Yeah.
me 2, right? X is 22, right? So I could just say val, what do I call it?
Increase.
Incur equals, and then I can just say that, right?
Yeah.
By giving it the name incur.
But the key really here is that this is a function. It goes from an int to an int.
And that's the type. Type
Yeah.
is a function from int to int.
And that is a valid type in Scala, okay? When you define one of these, actually, why don't you do that? Say val incur colon int to int
So just
equals.
go up here.
Oh, yeah. So that's actually a type.
Oops.
Okay?
Yeah, let me get rid of my extra space.
And that's perfectly valid to type it
Starts
like
looking
that.
like.
So that is a function type that we've given that. And you can use those in parameters, wherever you need to use it. You could say, I need a function from int to int. And then I could pass this into that. So what's next on the slide?
sorry.
That's all right.
Yeah, we can call it, so I can say
Oh, yeah.
incur of 10 and, well, 1, whatever. I don't want to say 10. I get 2. Incur of 2, I get 3.
Now, knowing what you know about Scala, what's this doing when you do that? Incur parens 1. Anyone? Okay, well, it's calling the apply, okay? Because when you have an instance of something and you give it the parens, it turns it into a call to dot apply with that thing. So this is a function actually has a method called apply on it, and it calls apply when we invoke it like
And
that.
it's another name for int to int is function 1. Int rocket int is a shorthand for the type name. It's this one. It's called function 1 because it takes one int.
Yeah.
That's the first type here. That's the argument type, and this is the return type.
Yeah.
So
Okay.
that is a trait, or like it's like an interface that has a. So
Okay.
that is a trait, or like it's like an interface that has a method called apply that takes an int.
Yeah. Okay. You can assign functions to variables, so we've seen that. One of the things you can do, of course, the function doesn't just need to be a statement. It can be many things. So when you say increase 22, it actually says we are here, and then gives you back the answer. Whatever's last in that block, that's what gets evaluated. Okay, now this is the important thing, though, and this is kind of one of the things that makes a functional language functional, is you can pass a function into other functions. Once you've got one of these things, you can hand it around like it's data. And there's examples of doing this kind of thing. Java can do this. It just has a really kind of clunky way of doing it right now. With Java 8, you'll have Lambda, and that will help a lot. But right now, if you want to, say, sort something, you can make a custom sort, but what you have to do is make a comparator. You have to define a comparator class, an instance of comparator class, and then you hand that in to the method that you're calling, or the sort method, and that does the work. That's the same mechanism. It's the exact same mechanism this is using. It's just that the syntax is a lot nicer to do it this way. Okay, what we would say is sort, sort, and then you give it a function. Just give it a function literal that you want to sort on. Job done. It does the same thing. So
Okay.
yeah, for each is an example. For each takes a function. For each takes a function of whatever it is that you're passing in, an item, say an int in this case, to unit. Okay, for each always expects a function that goes to unit. Well, it actually will work with anything, but it'll only give you a unit back again.
I'm just guessing this might work. I don't know. Oh, that does work.
But yeah, you can actually specify like something like sort, because you're going to be sorting two, let's say you're sorting two integers, and what you want to give back is a -1, 0, or +1, or a negative number, 0, or positive number. That's the function that you'll give it. And the function requirement in there will be int, int to int. That will be the definition. So as long as you supply something that satisfies that, you can put any function that you like in there, and it will do it.
That's funny. So here's one that converts the int to a string and then compares it for string sorting, and it does it. Compares it for string sorting, and it does it in a really weird way.
That's funny.
Okay, next.
Next. Okay, so short forms of function literals. This is the lengthy form. This specifies everything, including the type. It's perfectly valid to put the type parameter on there. But in a lot of cases, like where we've got some numbers, okay, we know that this thing's only ever going to be an int coming into this. So the Scala compiler can infer that. We don't need to supply it anymore. It knows that x is going to be an int, so we can use the int methods on it, like plus and greater than, stuff like that. But there's even more, okay? So this is where, you get into something called placeholder syntax. Now, underscores are kind of thrown out there as, this is another thing that's wrong with Scala, is that there's underscores all over the place. Well, the reason underscore is so heavily used is Martin and the Scala team wanted something that made stuff like this kind of easy to refer to, and a bunch of other things easier to use, but they didn't want to take up too many symbols, right? Every symbol they used is one less that you can use. So underscore was a pretty handy way of saying some kind of thing, okay? And that's what you can always think of, is underscore is always some kind of thing. In the case of placeholder syntax, it's the thing. So what you can say is filter where the thing is greater than 0. And that's the placeholder syntax. Some of the other uses of underscore is when you're importing, you say everything from a package, so it's everything. There's this typing that sometimes you say, I don't care what type it is, it can be anything. But pretty much it always works if you read it, that underscore is some kind of thing.
So another way to think of it is kind of like an anonymous variable, because I kept getting stuff. What I want to get rid of now is this guy.
Because you're only referring to it once.
I know I can't name it anything, so it doesn't have a name, I just call it underscore.
That thing.
So it doesn't have a name, I just call it underscore.
That thing.
The thing, yeah.
So okay. That's that.
Let's skip
there's a couple of other, the other placeholder syntax, not that.
So yeah,
that useful.
Yeah.
Converting a method into a function value. So if you've got a method like def sum of a and b, three of them together.
Sum 1, 2, 3, I get 6.
You can always make this into a function literal by saying val Adam. And
Adam.
Yep, and you
then-
can basically convert it into that.
Right. See, this is just basically, this is a function literal that takes the same arguments, and all it does is call that guy.
Yeah.
Call some method right up here.
Okay,
the name
so
of it.
now you can easily
Say
take
Adam
something that's
1,
already
2,
a
3, I
function
get 6.
or a
Behind the
method,
scenes, it's calling some.
and you can use that method in higher order functions now, so you can call through to them. Call through to them. So one of the things you can do is you can use placeholder syntax there as well. So instead of that whole thing, if you can go back to that,
Oh,
yeah, that's quite a long statement with all the types and everything like that. Instead of that, we can just say sum underscore underscore underscore, and that means each item in turn. So the first item, the second item, the third item, or first thing, second thing, third thing.
yeah.
Has to be the right number, but that works.
Yeah, so the rule is that basically you can use each one. This one is each parameter is used only once in the method body, right here that I've highlighted, and it's used in the same order they came in. See,
Right.
so the order is A, B, C, and it's used once each A, B, C. So that's why I can replace it
And
with
if you want to do
underscore,
anything
underscore.
different, you don't use underscore, just name them, and you're good to
Yeah.
go. But if you're only going to use them once, you're going to use them in order, which is quite often the case, like sort, for example. You get two parameters in. You'll say if this one is greater than that one. You're using
Well, I
them in
should say,
order. Yeah,
two.
that's perfectly good to do.
1, 2, 3, just so to
Yep.
prove that it actually works.
Now,
And
the
then let's
next
do another one.
simplification is that you don't need to supply the parens or the individual things at all. You can just replace the whole parameter list. So that whole thing, okay, it's still the thing works. But now we're going to say that whole thing, put that in there.
And what this is like is any method, you can wrap it in a function. So
Yeah.
a method is, you can call it, but you can't pass it to somebody or
Right.
stick it in a variable. But if you wrap it in a function object, you can. So all you do is just stick an
Right.
underscore after it. I can say print line val p equals print line underscore and say p of hello world. Right?
Yeah.
Oops.
Unit in trait function 0.
Oh, I wrapped the one without anything. That's not very useful.
Oh, okay,
That
yeah,
is that is because printline's over. I'm not sure why that is actually. Printline must be overloaded or something.
yeah, and it's taken the function 0 one. So yeah, that is pretty useless. But anyway, so one of the last things though is that Scala is very, very particular about not making you type anything that you don't absolutely have to. So we've just shown, if we go back, actually go back one slide, we've shown the long form, and then on the next slide we show like the shorter form and the even shorter form. In fact, if you just have a higher order function that takes, a function of int to int or something like that, and if you have a method already defined that takes an int and returns an int, you don't even have to do that. You just give it the method name, and it actually does that underscore stuff for you. It knows what your intent is. It's like you're handing in this thing. It's got the right type signature. I'm not going to bust you and make you do all this stuff. I'll just do it for you.
Yeah.
So that's what it does.
So when we say args for each print line, what we were actually saying was wrap the print line method in a function
Yeah,
and call it.
and that's just a nice little.
Call it.
That's just a nice little bit of syntax sugar that you get. Okay, what's next?
Partially applied.
Partially applied. Okay.
Partial application.
So another thing that you can do is, I think you've got a V missing off the front there.
Yep, I
Yeah,
did
there you
have
go.
a view missing.
You can take, wow, it's still gone. You can take a method that has three things, and you can choose just to leave one of them out. Okay, and that's known as a partially applied function because two of the arguments are already applied in there.
Yeah, look at the type.
And now what we've got is a function 1. So we fill in that middle one when we need to use it now. And the other two are always set. That's occasionally useful. You could see, for example, that you could take something like a function that always requires an output stream. And within a piece of code, you could predefine the output stream in there and get back a partially applied function that just takes the other arguments. And then you'll always get the same output stream when you use it.
So you
Okay.
apply arguments to functions. So this has applied the 1 already and the 3, but it hasn't applied this middle one.
Yeah.
So that's why 1 already and the 3, but it hasn't applied this middle one.
Yeah.
So that's why it's partially applied. Okay.
And if an underscore, oh yeah, that's just talking about the,
talked about that
well,
already.
that's called
Just do that.
ETA or ATA expansion, by the way. What do you call it, ATA?
I call it ADA, but this
Okay.
is Belgium, so
Yeah, ETA expansion. It's just sort of,
Enter's okay.
yeah. Okay, what's next? Okay, so now we'll talk about closures. So closures have been thrown around a lot. What we've actually been looking at, for the most part, there's been a couple of closures in there, but for the most part, we've been looking at functional literals right now. What makes a closure actually a closure is it refers to something in the scope surrounding the functional literal, but that isn't fully enclosed in it already. So an example is if we have a value of more, a variable of more, we can actually make a closure, and this is a closure now. We're saying the function is x plus more, okay? And more isn't defined, it isn't passed into the function, it exists in the scope around the function. And what that does, what literally happens here, is that it's called a closure because the function encloses around that other thing that you're referring to. It takes a copy of it. What it actually does is promotes it to the heap so that it exists for use within that function. So it's available to it. And so this becomes a closure. And now what we can say is function 2, and it increases our
Well, it
number of
returns
points.
3.
Yeah, returns 3. Now, if we change the value of more, and we call the same function again, we get a different answer back. Okay, we've just changed that value. It's on the heap. It's a var, so we can do this. The lesson you should take away from this is don't make closures over vars, because this is very confusing to a developer who's coming along behind you, who sees this function get called, the same function get called with exactly the same parameter and give back 2 different results. That's sort of a violation of one of the cornerstones of like pure functional programming. Pure functional languages, they don't allow mutability, so they don't have this problem. But Scala doesn't prevent you from doing this. And you know, it's another one of those rules. Scala doesn't stop you doing anything. If you've got a reason to do it, it's not your nanny. Okay, it's going to assume that you know what you're doing. So you can get yourself into trouble. Probably the best practice for something like this is if you want to do that, take an immutable copy of it first. Copy more into M in a val first, and then you're covered. It's
I
not
think we
going to do
should skip to
anything
this
now.
and then stop and let them ask questions.
Okay,
We have 10
yeah,
minutes
10
left.
minutes left. All right, go
So I
ahead.
just named the default arguments.
Okay, so yeah, one of the things that was added, actually it's been added for quite a while now, 2.8 I think. Was it 2.8 it came in?
I think so.
But it's very nice, is you can, when you define a method, you give the parameters names in a method, those automatically can be used as names when you call that method. So those names you can actually refer to. So, oh yeah. Now if you do speed, what did you call it? Distance equals.
You can do it this way.
And time equals.
So if you got a bunch of them, it makes it more readable which
Yeah.
one's which.
And actually,
You can
good
also change
practice
the
now
order.
is, and it's starting to become, and it emerges a good practice, is when you use Boolean flags in a method call, is to always name the Boolean flag, because seeing a bunch of calls with true and false in, you look at them and you're like, that means absolutely nothing to me. You look at them and you're like, that means absolutely nothing to me. What the hell is that doing? But if you say, shared equals true, or something like that, then it actually communicates more to the reader of the code what's going on. You're actually saying this thing is shared. So, yeah, and you can also have default parameters in there now as well. So you can give it a value that it will use if another one isn't specified. And that's very useful. So you can give it default parameters, and if you want to override them, you can put them in there, or you can just refer to the name and set them by their name.
Yep.
Very useful. Okay.
And that's, I think, good for, table recursion we've talked
Yeah,
about already.
we
I think we should take questions.
Yes.
So-
Obviously, the course that we do goes on for 2.5 more days and covers a lot more stuff than this.
It's a lot more interactive, too,
But, yeah.
and hands-on. But any questions?
Don't be afraid.
Yes. Oh, wait, hang on a second.
Oh.
I think it was like one of those really close ones, but I think he was first. I'll call on you next.
Why didn't your source
Oh, it did work.
It did? I think it did,
Yeah.
yeah.
Basically converted to strings, and then it was in alphabetical order. So,
Yeah, go scroll back up to
yeah,
it.
and so like 1, 0 is ahead of 2.
I think it might just be easier going back up to it in the... Are you going to define it?
I just have to find it. I was trying to go back up.
Why don't
to
you
it.
just scroll up in the...
Oh,
as
you mean
ran
like
it?
this?
Yeah.
Oh,
There you go.
thank you. Didn't think about that. So when I said toString, that means this F, this starts with F, this is a T. No, it's a 5 and a, oh, I don't know. Let's see, this is a minus sign. Yeah, what is it is in reverse, I don't know. I'll have to figure that one out. Somebody can probably
Huh, yeah.
figure it out.
Interesting. Any other
Yeah,
questions?
it's definitely
there
sorting
was-
it, because
yeah.
when I reverse it, it goes in that order. Right.
It's okay. I think it's okay. It looks at the first character, but it's reversed.
Yep.
Oh, right. Yes, it's reversed. That's
0,
right.
1, 5. That's
That's
right.
it.
It looks at the first character.
Yeah. Okay.
Yeah. Thank you. So you get to go next since you answered
Yes.
that question.
Slightly out of scope maybe, but what's your opinion about the language design of the companion object? Since I have the impression that sometimes working with nested classes is more powerful. But of course, the companion object comes with some convenience, just a very short...
Yeah, that's
Yeah,
a good
repeat the question.
question. So the question is, what's our opinion of companion objects and how they've been done versus nesting? Well, actually, there's all sorts of different things about that. The first thing I'll say, most general answer, is companion objects are still a slightly weird way of doing it, but they're not as weird as having static methods. Okay, so they're an improvement over static methods. That said, I got to say, I kind of like Smalltalk's approach on this, where you have a class with class-level methods, but they're true class-level methods. It's not some kind of static thing that's thrown onto the side. It's actually a class method and an instance-level method. But given the constraints that Scala had to work with as well, I think it's an improvement. Next thing I'll say is you can put objects inside of classes. You can put objects inside of classes, inside of objects, inside of classes. You can nest these things however you like. And that also happens a lot. So you can define an object inside of a class. It won't be a companion object. It'll actually be a nested object inside of that class. But that's also very useful for all sorts of things. I mean, I've actually just been using them with implicits. You can make implicit objects inside of a class that are then kind of ubiquitously available inside of that class, and that can be very useful. What else?
Anybody else?
Oh yeah, no, that's
a
probably
good
good.
answer.
We can take that one offline. If I can talk about that for
4
hours.
minutes left. Anybody else have a question?
Yes.
Yes.
I'd like to ask how Scala developers treat backward compatibility. For example, you mentioned
Oh, backwards compatibility in
mentioned what?
Scala.
Okay.
Yeah, so backwards compatibility in Scala, it's pretty good for the most part, but there are a couple of particular gotchas.
I'm not sure I understand the question. Can you
we-
repeat the question?
Yeah,
The
the
full
question is, how do we treat backwards compatibility in Scala?
backwards compatibility with what?
Well, with Scala.
in the language itself and that library.
Yeah,
You mentioned this example, some feature, I think it was implicit facto.
yeah.
Now there is this warning, but in future version it will be an error or something like this. So it can break your code, right?
Right. So yeah, the example earlier was the implicit conversions are now a feature that has been moved into something that you have to import, whereas they were just available before. And in future versions, if you don't import them, it'll actually be an error. This is one of the things that I think Java got wrong, and Python and Scala have got more right, which is that they're not deliberately going to break your code, but at the same time, we're not stuck with language decisions that were made 15 years ago that make absolutely no sense anymore. Okay, there is some scope for allowing the language to change, and that includes taking things away as well as putting new things in that are incompatible. So I actually like it. It's never that hard to take old Scala code and port it up to the new stuff. It's really, if you need to make any changes at all, it's pretty quick to make them. But I like the fact that the language and the libraries have continued to improve. That's the good side. The bad side is that there's another specific problem with backwards compatibility in traits in Scala. We haven't really talked about traits because we didn't get that far, but traits are the kind of multiple inheritance model that Scala has. They're very, very powerful. The problem is that because of the way the JVM is written, if traits change, then you lose binary backwards compatibility with earlier versions. And that causes a sort of ripple effect when a new version of Scala comes out, that you have to wait for the other. It's usually a compile, just a recompile, but things have to be recompiled. Otherwise, they're not binary compatible anymore, and it breaks. So you often find yourself waiting for a couple of weeks after a new release of Scala, while all the libraries that you depend on are recompiled to the new
So
version.
that is one of the main pain points. Compiler speed was one. Another is binary compatibility. So
Yeah.
the way it works now, it's been stabilizing over time. Is it called, like, if you say 2.9,
Small releases.
2.9 anything are binary compatibility. Binary compatible. So that lasts like a year and a half, or however long between the major releases. Then 2.10 actually can break binary compatibility with 2.9. You will probably have to recompile your program. But 2.10.1, 2.10.2, 2.10.3, et cetera, will all be binary compatible with 2.10.0. So all you need is a library built up with 2.10.anything. Well, 2.10.0 is what everybody should build against. And then you won't have to worry about it until 2.11.
Yeah.
Yes, one more. We have time for one more question. May have to be quick.
Is this binary incompatibility going to change as a result of work in JVM for 8?
Is the binary compatibility going to change as a result of work in the JVM for Java 8?
Not Java 8.
Probably not anytime soon. There might be a few things like method handles that might help a bit, but the real change, binary compatibility in Scala, while we've got traits, is going to be hard for the foreseeable future. That doesn't in any way make me want to abandon traits, because traits are way too valuable to get rid of.
Way to implement it in terms of default methods of Java 8?
Is there any way to implement
that
that
doesn't
as
help
a
with the
default?
binary compatibility.
Yeah.
What he said is that the method handles, I think, is what you mean. But anyway, our time is up. We can talk afterwards. But
Yeah.
not much help coming from the JVM, I don't think. Well, thank you for coming to our festivity. And I think there's probably lunch served downstairs, right?
And if anybody wants to do the hands-on lab this afternoon...
No, it's tomorrow afternoon.
No, the hands-on lab is this afternoon.
Oh, thought it was tomorrow afternoon.
No,
If it's not this,
pretty sure.
if not, then that means
Can
they
I
have
get
less
here
time
for a
to
second?
cram.
What you need to do, if you want to do that, is go to Scala Cohens. If you look up Scala Cohens online, scalacohens.org, and if you want to come to it, you've got, what is it, an hour before the... Come on.
Go on.
There we go.
There you go.
If you go to the installation and getting started, it doesn't take long, but that's what you need to do to get Scala Cohens running for the afternoon thing. And Bill and I will just kind of be there if you've got any questions. It'll be like a supervised hands-on session where we can answer questions and stuff. Okay, thanks.